This is the story of the discovery that broke the rules of physics, and what it might mean for how the universe and everything inside it actually began. Here's the strange part. The astronomers who found this object weren't even looking for it. A team led by MIT researcher Rohan Naidu was running a survey they'd nicknamed Mirage or Miracle, using the James Webb Space Telescope to hunt for the earliest, most distant galaxies ever formed, dating back to when the universe was only a few 100 million years old. Their real goal was simple: find galaxies that genuinely existed that early and rule out ones that only appeared to. Because that's the puzzle they were chasing. For years, JWST kept spotting galaxies in the deep past that looked impossibly bright for how young the universe was at the time. Some of those bright objects turned out to be real. Others turned out to be something else entirely, a mirage rather than a miracle. While scanning through JWST's images looking for targets, one object stopped the team cold. A single dot. Very red. Very bright. Different from everything else in the frame. They had no idea, at that moment, that they just found something that had never been observed before. Section 2. Why red usually means dust. So why did one red dot stand out from thousands of galaxies? To understand that, you have to understand what red usually means in astronomy. When something in deep space looks unusually red, astronomers' first instinct is dust. Cosmic dust, tiny particles of soot and ash scattered through galaxies, scatters blue light far more efficiently than red light. That's the exact same reason sunsets on Earth turn orange, and it's the same reason smoke from wildfires can turn a clear sky a deep, hazy red. Robert Simcoe, one of the study's co-authors, has compared this red dot's appearance to exactly that kind of smoke-veiled sky. Dust in space works the same way, filtering out blue light and letting the red through. So the natural assumption was that this object was simply a normal galaxy wrapped in an unusually thick veil of dust. Case closed. Except it wasn't. Section 3. The signature that didn't fit. When the team studied the object's light more closely, something didn't add up. Below a certain wavelength, the light didn't just fade the way dust would cause it to. It vanished. Almost completely. Sharply. Like hitting a wall. This kind of sudden drop-off has a name in astrophysics, a Balmer break. It happens when dense gas in a star's outer atmosphere absorbs a very specific range of light. It's a completely normal signature, one you can even see in stars close to home. Vega, one of the brightest stars in our night sky, shows this exact pattern. But here's where it got strange. The Balmer break in this object was the deepest one ever recorded, in anything. Deeper than any known star could produce. That single fact ruled out an ordinary star immediately. Whatever this was, it wasn't behaving like anything in the astronomers' existing playbook. Then there was a second clue. When they analyzed the chemical fingerprint hidden in the light, they found almost nothing except hydrogen and helium. No heavier elements. No metals. Nothing that would typically appear in an aging galaxy or a mature star system. This object was, in Naidu's words, singular in nearly every way they measured it. Section 4. Testing the impossible. So the team asked a strange question. Could you actually create that exact shade of red using nothing but hydrogen, with no dust involved at all? They ran the simulations to find out. And to their surprise, the answer was yes, but only under one very specific condition. If the hydrogen was packed into an extremely dense cloud, dense enough that it would behave less like a thin, wispy nebula and more like the actual surface of an enormous star. That was a real breakthrough. It meant the red color didn't require dust at all. It could come from something else. A massive, ultra-dense envelope of hydrogen gas, acting almost like the outer atmosphere of a star. But that explanation still left the biggest problem completely unsolved. Even if the color made sense, the brightness didn't. This object wasn't just glowing. It was blazing with roughly 100 billion times more energy than any star its size could physically generate through nuclear fusion, the process that powers every single star we know of, including our own sun. Nuclear fusion has hard, well-understood limits. No star, no matter how massive, can cross this particular threshold. So if fusion wasn't the power source, something else had to be. Section 5. Adding a black hole to the model. There's only one process in astrophysics known to generate energy at that scale from that little mass, an actively feeding black hole. Black holes don't need fusion to release enormous energy. As matter spirals inward toward the event horizon, it accelerates violently, heats up through friction, and radiates intense light and energy before disappearing past the point of no return. It's one of the most efficient energy-generating processes physics has ever documented. So Naidu and his team went back to their simulations and added a new ingredient, an actively accreting black hole, sitting at the center of that same dense hydrogen cocoon. They tested different black hole masses, adjusted the surrounding gas density, and compared the resulting brightness their models produced against what JWST had actually observed from the real red. One combination matched almost perfectly. A central black hole roughly 100,000 times the mass of our Sun, wrapped inside an extended envelope of hydrogen gas roughly the size of our entire solar system. In that scenario, the black hole plays the role nuclear fusion normally plays inside a star, generating the energy. The hydrogen envelope plays the role of a stellar surface, absorbing and re-emitting that energy so it glows outward like starlight. A black hole disguised as a star. Section 6. Naming the first one. The team named their discovery MOM BH1, a name that carries the survey it came from, its brand new classification, and an implied promise that it's likely the first of many, not the only one. Ever since JWST began operating, it has kept spotting these unexplained little red dots scattered across nearly every deep field image it's taken, dozens of them, sometimes hundreds, appearing throughout the earliest chapters of the universe's history and then essentially vanishing from images of the more recent cosmos.